The article titled, "Challenging Quantum Mechanics with a Crystal," is a news release from the Department of Physics at ETH Zurich. The article discusses a recent study conducted by Dr. Matteo Fadel, a Bronco Weiss Fellow at ETH, along with Professor Yiwen Chu's group at the Laboratory of Solid-State Physics, and colleagues in Denmark and Germany. The researchers have managed to put a microgram mass crystal into a quantum superposition state to test the validity of quantum mechanics in this macroscopic regime. The results of this research, published in the scientific journal Physical Review Letters, could potentially test quantum mechanics using heavier objects than ever before. The researchers used acoustic wave resonators, which are essentially small slabs of sapphire that vibrate. These vibrations are then measured to induce vibrations that represent quantum mechanical superposition states. The crystal is coupled via the piezoelectric effect to a superconducting circuit that acts as a quantum bit, or qubit. The team was able to create quantum mechanical superposition states of a sapphire crystal consisting of 10,000 trillion atoms. They cooled the crystal, which vibrated around 6 billion times per second, down to 1/100th of a degree above absolute zero, to minimize thermal fluctuations. After putting the crystal into a specific quantum state, the researchers detected its state after a variable time via the qubit. This allowed them to determine whether the vibrational state of the crystal was truly quantum mechanical, or whether it could be described by classical mechanics. The results obtained by Fadel and his collaborators at ETH put an upper bound on how large a hypothetical term might be. If the Schrödinger equation needs to be modified, this would have important implications. For example, for quantum computers and sensors, as the numbers of qubits in those quantum devices become increasingly large, decoherence effects due to their sheer size could put as yet unforeseen constraints on their functionality. The article provides a detailed explanation of the experiment, the methodology used, and the implications of the results. It also includes images of the sapphire crystal resonator used in the experiment and the coupling of the crystal to a qubit. The article concludes with a reference to the original research paper, published in Physical Review Letters.